All right, here's a question where we're asked to graph this polynomial. And using these steps that they give in the textbook on how to graph it. So the first says use a leading term test. This thing is written in the proper order, so my leading term is x to the fourth. It's even, so it starts and ends in the same direction. It's positive, so it starts and ends going up. So it'll be sort of like a W graph. Okay, other thing I know right away about it is the y-intercept is 6. I guess maybe I should follow the rules. Use the leading term test, got it. Find the zeros of the function. Okay, so finding the zeros of the function. And zeros and x-intercepts are really the same thing, where you get the same numbers. I guess they're a different thing, a different idea, but you use the same numbers. So let's try it. Let's use syntactic division. So 1, minus 1, minus 7, 1, and 6. I'm going to try 1. That's my favorite one to start with. 1 times 1 is 1. Add 0. That'd be 0. Add negative 7. Multiply. That's negative 7. Add. That's negative 6. Multiply is negative 6. Comes out with 0. Yes. So I got 1. Let's try another one. So I still have 6 there. Maybe 2. I don't know. 1. 1 times 2 is 2. That'd be 2. That'd be 4. Negative 7 plus 4, that'd be negative 3. Is that right? Yep. 2 times negative 3 is negative 6. Uh-oh, that doesn't give me a 0. Did I do everything right there? It felt so good. Yeah, I did everything right. That's not right. Okay, so let's try a different number. Instead of 2, let's try maybe minus 2. So it'd be a minus 2. Add, that's minus 2. That'd be a positive 4. Is that right? That'd be a negative 3. Positive 6, 0. Yes. Okay, so far for factoring, I have x minus 1, x plus 2, right? Those come from there. And then I have x squared minus 2x minus 3. To factor just that piece, I think it would be an x minus 3 and an x plus 1. So all the factors I have are those. Now, if they say let f of x, which is the function, equals 0, then I want to find the zeros for this function. So the zeros would be 1 and negative 2 and positive 3 and negative 1. So these are the zeros. Is they want to know what the x-intercepts are. The x-intercepts would be 1, 0. That's the point that the x-intercept would be. Negative 2, 0, 3, 0, and negative 1, 0. Okay, so that's my zeros and x-intercepts. Now they say choose a test point in each interval to determine the sign of all function values in that interval. So if I graph this thing, so at 1, 0, something happens. At minus 2, 0, something happens. At 3, 0, 2, 3, something happens. At negative 1, something happens. So they say find a test value. So what I could do is, like, I want to find the test value in between, say, this point and this point. So I want to know if it's up here somewhere or if it's down there somewhere. Really, by the graph, I'm thinking that the graph goes something like this. And that's what it's going to look like. And really, that is what the graph is going to look like. But I can find some points, like in here, if I say plug a 0 in. Well, if I plug a 0 in, that's the same thing as the y-intercept, right, where it crosses the y-axis. I already know that's positive 6. So this point right here would be 0, 6. But say if I wanted to find this point here. So just to confirm that that's going to be negative something, what I could do is plug in a positive 2 everywhere I see an x here and see what that comes out to. Let's just do that for that one. So it would be 2 to the 4th minus 2 cubed, brackets, minus 7, 2 squared, plus 2, plus 6. So that would be 16, whoops, 16, minus 8, minus 28, yeah, that's right, plus 2, plus 6. So 16 minus 8 is 8. 8 minus 28 is negative 20, plus 2, plus 6. That'd be a minus 18, plus 6, that'd be a minus 12. So that point right down there will be 2 and minus 12. So that sort of confirms within this interval from here to here that the graph should be negative, and that's how, if I knew sort of the general flow of the graph, I sort of knew that's where it would be. Okay, then they say find f of 0, that gives the y-intercept, that's always that number. If I put a 0 in everywhere I see an x, all of those cancel, and so it'd be 6, got it. If necessary, find additional function values. So here, if you wanted to, you could say go to negative 3 and plug a negative 3 in everywhere you see an x and see what it comes out to, and it should be positive something up there. Then it says, as a partial check, use the fact that the graph has at most n x-intercepts. So this is n, so 4. So it has at most 4 x-intercepts. 1, 2, 3, 4. Got it. At most n minus 1, so that 4 minus, or 3 turning points. 1 turning point, 2 turning points, 3 turning points. Yep, that checks out. Multiplicity of zeros can also be considered. In this particular graph, we don't have any multiplicities. Okay, hopefully that helps you with that question in just understanding, especially that interval idea. You can use that, but typically if you find the x-intercepts and you know what that the general shape of that graph is, you can pretty well peg where that graph is. Okay, hopefully that helps.